So we've been talking about the natural resources that the earth provides humans, and the third one we're going to talk about is air. So the first one we talked about was water. The second one we talked about was soils. And the third one we're going to talk about here is air. So these are the three abiotic sources of life. So these are sort of the necessary, so they're needed for life. If we don't have water, well, we dehydrate to death. If we don't have air, we can't breathe. If we don't have soils, we can't grow food, or animals can't eat, and then we can't eat the animals. So what is air? So we have our atmosphere. And this is just, so we do have molecules that are spaced apart from each other. So what do I mean from this? I don't think I talked about solids, liquids, and gases, but when we have soils, all of our little molecules are really close together. So here is how close little molecules and particles are when we're dealing with soils. When it comes to water, they're further away from each other. So there's more space in between the little particles. And then when it comes to air, there's actually a lot of space between the particles. So it's a gas instead of a liquid or a solid. And the majority of our atmosphere is actually made up of nitrogen. So the number one molecule or number one element in our atmosphere is actually nitrogen. And that makes up 78, almost 80% of our atmosphere. It's a very inert molecule. It doesn't like to make friends with anyone. It doesn't like to hang out or interact with anyone. So it's a nice neutral gas to have in our atmosphere because it doesn't make changes. So this is where it sort of keeps everything, keeps it steady. And then our number two component, the reason why we have life on this planet is our oxygen. And this is at 21% or about 20% oxygen. And so this is why life exists, because we need oxygen in order to breathe. So thank you, oxygen, for allowing us to breathe. We don't want too much oxygen because it can become explosive. There's a reason why you're not supposed to smoke or have an open flame in a hospital. That's because a lot of the patients are on oxygen. And if you put an open flame near the oxygen, you can have a huge explosion. And then all the other gases are just sort of minuscule marks. So I'm gonna put in here that we do have CO2, and that it is very, very small. And the reason why I'm talking about CO2 now is because with global warming talks and everyone saying, oh no, carbon emissions, you might think, well, what? It's only a very small percentage of our overall atmosphere. But we'll talk about why carbon dioxide, while a small component, has a big impact on our atmosphere. So we actually divide our atmosphere into 4 different layers. And this is based on it's actually based on the density of molecules and other features as well. So we'll talk about the different, I'm going to make this smaller. We'll talk about the different parts that are defining for each of our layers. So at the thermosphere, this is actually our highest layer. So it's the top layer of the atmosphere. You may have heard of other many layers, but we're just going to stick to these 4 because it's easier this way. So this is the highest layer. This is the least dense layer. So if we were to look at the little molecules up here, they would be spread out like this. So our little nitrogen and oxygen molecules are very far apart from each other here. It is also the hottest layer. You might not think this, but it's true. That's why it's called thermo, because it is actually the hottest layer. And what happens up here, this is where we get our northern lights. So if you've ever heard of the northern lights, that's what the picture is showing us. These purples and greens are actually the northern lights. And this is where you would find low orbit satellites. So we have, we've got our top layer, our hottest layer, and it has the northern lights and our low orbit satellites. So that is our top layer. Right below the thermal layer, we have what's called the mesosphere. So our meso just means middle. It's sort of just smack in the middle of our atmosphere layers. This is actually the coldest layer. It is more dense than the thermosphere, but less dense than the stratosphere. So what do I mean by that? So the molecules are a little bit closer together compared to what we see in the thermosphere. And then something else, just to sort of keep things organized, this is where meteors burn up in our atmosphere. So if you've ever watched like movies where space shuttles are coming back into our planet's atmosphere and you start to see them burn up on the bottom side, that's happening in the mesosphere. Oftentimes the space shuttles sort of hang out in the upper thermosphere or right above the thermosphere. So it's not until they get to the mesosphere that you start to see the glow or the burning of things in space shuttles. And that's because this is where the atmosphere actually becomes dense enough for friction. So the meteors burn up because we actually have enough friction to produce heat. So when you guys rub your hands together really fast, it gets warm, right? Well, that's friction. So there isn't enough stuff rubbing up against each other until you hit the mesosphere for things to start burning up. So then that's the mesosphere there. Our next layer, and probably one of the two important layers that we have, is the stratosphere. And the stratosphere is where the ozone layer is located. It is actually, and the ozone layer is actually the protective blanket of the planet. You may have heard of You may have heard of the ozone layer. So it's the protective blanket. What this means is it actually bounces harm rays back into space. So then we don't have to worry about those harmful rays coming down and hitting us down at the surface level. So the big thing that the stratosphere is really known for is the ozone layer. Something else that sort of happens here is you can get long distance flights. So if you are traveling across the ocean from America to Europe or Asia, you're probably hitting the lower stratosphere just because it's a lower, smaller distance when you go up higher. So if you think of a rocket going up in straight up and then coming straight back down. It won't come exactly straight back down because there are forces at work. And then the stratosphere is thicker than the mesosphere. So we do have more particles. Oh, look, there is a plane flying here. I didn't notice. There's the little plane. So there is all sorts of fun things happening in the stratosphere. But the one that we really interact with the most is the troposphere. So this is the bottom layer. This is where life occurs. I'm also going to say this is where weather occurs. It is also the densest layer. So when we're talking about the atmosphere and changes that we're doing to air and air pollution, we're really talking about the troposphere. So most of our talk about air and air pollution is actually dealing with the troposphere. So it is actually the most dense layer. So I'm just trying to show you there's lots and lots of little molecules really close together compared to all of our other atmosphere layers. And then if you are in space and you're looking at the ozone layer, the atmosphere, this is sort of the atmosphere of Earth. You can see it sort of fades out here because there really is no distinctive boundary. So there's sort of little buffer zones. So don't think it's really nice and neat and easy to decipher one layer from the other. But you can see how nice and big, well, it goes up here somewhere, our ozone layer is. If we were to compare Earth's ozone layer to other planets like Mars, Mars's atmosphere is maybe this thick. So Mars has a very thin atmosphere. So it cannot support life like the Earth can because it doesn't have as thick an atmosphere, nor is it made up of oxygen and nitrogen. A lot of it is carbon dioxide. So those are the layers of the atmosphere. We will be spending most of our time down here in the troposphere. We may talk a little bit about the stratosphere, but a lot of what we're going to talk about for this chapter is down in the troposphere.